Hello and welcome to Learn CSE Academy. In this video, I will teach you what is an assembler. Assembler is a type of computer program that interprets software program written in assembly language into machine language code and instruction that can be executed by a compiler. What does that mean? The source code, which is written in assembly language, will need a assembler to convert into machine code because our computer understand only machine level language, which is in form of binary 0 1 0, or we can say high and low level. So the program which is written into assembly code, which is basically we could say the mnemonic code form, and this particular program needs an assembler to convert into the machine code. So assembler enables the software and application developers to access, operate and manage a computer's hardware architecture and its component. An assembler is sometimes referred to as the compiler of assembly language. It also provides the service of an interpreter. Assemblers comes under the language translator. So what is a language translator? Because we need to interact with the computer hardware, and in the previous video we have discussed that an operating system is work as the interface between the user and computer hardware. So operating system is one of the main module of our entire computer system, where we need an interface to interact with the computer hardware or to get the services from the computer. So operating system module, the language translator is inbuilt into the operating system, where we have so many type of language translator broadly divided into three categories, that we have interpreter, compiler and assembler. So before moving on, first understand what are the level of languages, because we are talking about the level of languages like user level languages, what is the low level language, so what exactly these languages are. So first of all, we have low level language, which we could also say the machine level language or hardware level language, which our machine could understand but not understand by the human. Of course we could understand, but we need more time and to convert the into the human readable language. So basically binary language 1 and 0 is called the machine language, which is difficult to write, difficult to code in this particular language, because all the code first we have to convert into binary language and then we will feed into the computer hardware, which is very fast to execution. Why it is very fast in execution? Because it is not need to translate from hard level to low level language, because it is already in low level. So it is machine dependent, because the code for one machine will not be work on the another machine. So a machine specifications include what type of operating system it is, how many types of data it could transfer at one go, what are the process types. So all of these things we have to take into consideration before writing a code, before writing a program into low level language. Moving on, what is a middle level language? Middle level language, it is a mnemonic code which is called the assembly level language. The mnemonic code understands, that is add, subtract and move. So full form of add is addition, full form of sub is subtraction. These are the codes, these are the commands which is written into the mnemonic form. And mov said move code. Easier than the low level language, because we can easily interpret what these commands meaning is what, because they are in the short form. And machine dependent in case of assembly language, which we understand in the later on. So what is the high level language? High level language is also said to be user level language, which is understood by the user, and it is mostly the English like language. We do coding in the programming language like Java, C, C++, and so on. We have so many programming languages nowadays. So it's just taking an example that in Java we are writing a code in simple like English like language, which is very easy to understand a human. So why do we need to translate the machine language? That is why it is slower. So machine dependent in case of assembly language and machine independent in case of the low level language. And machine independent because a program written in high level language, it is portable. We can port our program from one machine to another, and we can implement our program which is written on one machine and can be executed onto the other machine. For example, a piece of code written in high level language may execute in this machine and can port into the another machine. That program will work exactly the same which is work onto the previous machine. So we have a translator here. So translator we have, first we have assembler, compiler and interpreter. What is the difference between these translator? The word of a machine language are called instructions. So instruction is basically what? Instruction is the steps which we written how to solve a particular problem. So we can say how to solve a problem or sequence of instruction or sequence of instruction to solve a problem is called a program. Each instruction calls an action by the CPU. In instruction, we specify that which action need to be taken by the CPU in order to solve a particular problem, such as reading from a memory location. Of course, we have a memory in which we have stored our data. So in instruction, we have written a particular syntax followed by the properties of a language which is inbuilt, and we have to follow all the rules which is already written into the language, and we have to follow those rules, and by writing the instruction and given that instruction to CPU, and after giving that instruction to the CPU, first we have to translate that instruction in the form which our machine could easily understand. So a program is a long list of instructions which we already know that are executed by the CPU. So instruction is what? Instructions are the pattern of bits. Different patterns correspond to the different commands to a machine. For example, we have a command that we have a variable a and in which we are storing the addition of two variables b and c. So we have an empty variable called a and we have another variable b and c in which the value b having 2 and in the c we have value 1. So when we given this instruction in our program, first it will check what are the operator it's using and what are the operand in which this operation is going to perform. So in B we have the value 2 and in C we have value 1. So 2 plus 1, the final value 3 will be stored into the variable A. So such kind of instruction, we have other type of instruction as well which we given into our program, and then this instruction must translate into the level of the language which understand by the machine hardware. So how our CPU is going to get the values from these variables which are stored into the memory. So somewhere there is a values of these variables 3 and 2 is stored into the memory, and we have to take these values and that import into our program, do some calculation and store the value and again store the final value into the memory. So this is how its process is going to be executed. So what are the machine level instruction we have? Take an example of an add instruction, because this is a high level language program example, but here I am using assembly code program. We are in the function of add. R1 is a register, R2, R3 is also the register, operator is here plus operator we are using, and this code is written into the assembly language. So broadly, what are the part of instruction we have? Opcode, we have the verb, what operation to perform. Opcode is the operation, which operation we need to follow, which operation we want to follow. Here we are using the add operation. Apart from this, we can use subtraction, multiplication and division as well. So these are the mnemonic form of the operation which we could use into the assembly level program. So in operand we have some nouns and what to operate upon. So operand we have the registers here, that on register value we want to apply this operation. In source operand where the values will be came from, and destination operand the result will be stored in which particular operand. So this is how an addition instruction is written into the assembly language. Here, what are the language translator? Broadly, we have interpreter, compiler and assembler. So here is a short comparison of these language translator. First, we have the What are the translator, compiler and assembler? So translator is a high level language which translates the high level language program into the machine code, whereas what this compiler does, compilers also translate the high level language into the machine code, and assembler is convert the assembly language program into the machine code. See, here we have the high level language, and in the middle of high level language and low level language we have a code like assembly program. So assembly language is a kind of one level up to the low level language and one level down to the high level language. It's kind of a middle level language of the program. Translate source one line at a time. It is, I think it's an interpreter here. Interpreter is translate one line at a time of a program. We have 10 lines written in a particular program. So interpreter, what does interpreter do? Interpreter translate one line at a time, whereas compiler translate the whole code at the same time, and assembler use the processor instruction set to convert. So assembler here use the instruction set. Here instruction set is stored already in the memory, and assembler use that instruction set in order to convert the instruction into the low level language. So what is needed every time you run the program? And compiler will need only one time, where we can use the executable file here. Returns a list of error found and on which line. It will return all the errors which find in a particular line, and it will report that, whereas compiler will inform you of the first error it finds. So it will inform you, whereas we have a program and the first error occurred, the compiler will automatically tell us about that. So in interpreter runs more slowly and is being translated every time the code is run. Obviously interpreter is slower than the compiler because compiler execute and translate the entire program at once. So it will be quickly as compared to interpreter and assembler. Assembler runs quickly as conversion between the two low level language is just reliant on the processor instruction set. So what are the common type of instruction we do have when we talk about the assembly language? So broadly we have three kinds of instruction. First we have the move, where we are moving the data from one place to another, whether it is given the data register directly a value. We have a register R1 and we are giving the value 5 directly, and then move data from a memory location to a register. We are providing the memory location. Let's suppose we have a memory and there are some location 100 and value stored at this location is 5. So we are giving the address of the location and where that the value of that particular location will be imported into the register. Read and write data from a hardware device, we directly giving the values to the registers. Then we have computation. Computation is most important instruction where we are actually operating on the data. And operation are called addition, subtraction, multiply and divide. What are the perform of the bitwise operation, where a single bit is moved when compare two values in register, whether they are greater than, less than, equal to, not equal to. So this kind of operations we are perform. And then we have the control flow. Control flow, we are using the jump instruction to jump to another location in the program and execute the instruction there. Jump to another location if the certain condition holds. What are the assembly language instruction statement elements? So total 3 instructions we have: opcode, data definition and assembly directives we have. What are the types of assembler we have? So broadly assembler categories categorized into two pass: one pass assembler and multi-pass, or generally called the two pass assembler. Assembler which generate the instruction and on the basis of number of phases which is used to convert the machine code. So assembler having the two types, one pass and two pass. One pass assembler perform the entire program, entire lines of code, conversion of assembly code to the machine code in one go, whereas in the two pass assembler first process the assembly code and store values in the opcode. So in the first pass, what multipass assembler do? Symbol table and opcode table are defined and keep a record of the location counter and process the pseudo instruction. So a symbol table and opcode table is maintained in the first pass, and then second pass finally convert the opcode into the corresponding numeric opcode value which is already into the table, and then generate the machine code according to the value of literals and symbols. So this is all about the assembler. We have probably two types of assembler, one pass and two pass.